Here are 7 times 7, 49 tiles. It's the same tiles. 1, 2, I think I better show it here.
Can you erase what you have?
Yeah,
on
just
there?
put it
I hate to say it, I can't. It takes a special spray and it takes a lot of elbow effort. That's the problem. I'll try and work right over here. How's
That's
this?
good.
Well, why don't I change colors?
Well,
I don't know how well it'll come off. Should I go to black?
uh,
Let's see what happens
It
with it.
doesn't come off.
But it's not.
No, I mean it comes off. I mean,
It can go off on this one. It's just true and false. It either is or it isn't.
I don't know. No,
Here we go.
That's not the logic.
But well, that's the.
That's not on or off.
got to start way up there.
That's the knowledge, and that's the unknown.
Okay.
Yeah, I don't know.
Remember the pattern that really made this? We did the multiplication series and everything, but really the most important thing, I think, is these doubling circuits and the 396, 39, and the, okay, everyone follow me? So we have 2 things, the doubling circuits and the 396, 693. Really 3 things, but I'm just lumping the doubling circuits together. Okay. So and remember it's going 1, 2, 4, 8, 7, 5, and it's making this pattern over and over again. Okay, I think this will be kind of fun. Okay. So I'm going to draw. It's kind of hard for me to do. How many have I done there?
Can't tell.
Okay.
Black.
1, 2, 3, 4, 5.
Black's pretty hard to see.
Black's
Do
worse.
you have green?
No, I should. I wish I did have green.
Let's do it with blue then.
I think I better buy a green. Okay, let's do red. Okay.
Pretty blue.
I mean
What was
blue.
your original
1,
word?
2, 3, 4, 5. Okay, 1, 2, 3, 4, 5. Is someone laughing? What was that?
You need some fruit.
some fruit.
Right. Thanks.
Bananas.
Hey, I accept. What
Yeah,
kind?
there's a banana.
Yeah, do the banana trick.
Okay, banana trick time. Okay, watch
There's
this.
some potassium.
We were all going to go to dinner tonight after I was going to invite everybody to what restaurant, Bob?
Raw experience.
The Raw Experience.
I'm hungry now.
Okay, is this banana? Does it look round? It's too late.
It looks very good. Whenever.
You're going to want it after my little pedlies go over
Right
my
on the
finger?
street, I could get about 20 of those.
Where? You can eat that many?
No, but for everyone. You know, just
How can you do that? Now look, you see I'm squishing it? Is everyone watching this? I'm making it malleable. Is that malleolating it? And watch how it breaks.
Oh, I do this all the time.
You play with your food all the time?
No, but I do this. I don't know why.
The banana split.
Yeah. Funny thing is,
No.
all the
Sometimes
stuff that
it's
you
easy to
show
do that.
me, it's so innate. It's so like, what do you call it? Intrinsic or something. It's just, you know it. When you say and you explain this stuff, it's like you go, oh, of course. That's when I was like 3 years old, staring at the floor, and I saw all these patterns within the tile on the floor, and you go, you know what I mean?
It's
Well,
3 parts.
you may go
I know
crazy.
exactly what you mean. You remember when you were 3-year-old staring at the floor?
Staring at the thing and going, oh, there's something really there, but I don't know what it is.
It's a pretty good
In
memory.
the public bathroom in cafeterias, you see meeting the floor, it's like you're just like diving down.
Right.
By threes.
So we agree, we're back to thirds again? Okay, so much for the banana experiment.
I need a banana.
I think
It would actually make me tired. I don't eat till I'm done presenting.
Yeah, I do.
Oh well,
So what was your original question here? How does this relate to
I'm not going to eat it.
artificial intelligence?
Yeah, well I just,
But you just outlined the circuit there, so you might as well, I mean, you outlined a 5 by 5 grid.
right, which is the artificial intelligence.
Wow.
We're coming to that. Okay. Let's see.
I don't really think that a computer could do that, though, you know, because the element that it would be missing is what you said at the very beginning, was love. And a computer that's trying to think for itself, that doesn't have the element of love, is going to end up doing something negative.
Except I learned a long time ago that the second you say no or it's not possible, you're usually wrong.
Yeah.
But I agree with you. Something that is strictly three-dimensional, which, you know, does not have the capacity of the higher dimension, omni fourth. There's only above the third dimension is the omni fourth dimension. There's no 6, 7, 8, 9 dimensions. The omni dimension is the 9, and the fourth is the 3 and 6 are the fourth dimension, which represent magnetism. 3 and 6 is magnetism. The 1, 2, 4, 8, 7, 5 represent electricity, In between the 1, 2, 4, 8, 7, 5, you always have the 3 and 6, which is the magnetism, and in between the 3 and 6, you always have the 9, which is the theta particle, the etheron flux, the spirit. As far as making things and doing things, though, in artificial intelligence and stuff like that, I really cannot comprehend anything that cannot be done using this. Okay. So let's take a look at what we're doing with 5 boxes. This was the number 5, was right in the middle. We had 5 like that, correct? 5 was in the inside.
Right.
Okay. So we come down 5 now, we're going in odd amounts. 1, 2, 3, 4, 5. So we come down 5. Okay. And where's 1, 2, 3, 4, 5? So this was it right here?
Yeah.
Okay. And what's the number in the center?
7.
Well, that's exactly what belongs. Because and what's going to be if there's a 5 there and a 7 there? There's going to be, no, there's got to be an 8. Because 8 doubled is 7, 7 doubled is 14, which is 5. So sure enough, we count down 5. Okay, is that 5? 2, oops, sorry. Okay. And what's the number in the center? Okay. And what's the number between 4 and 8? A 4? Well, did I do it right? 7, 1, 2, 3, 4, 5, 8. 8, 7, 5. So there's got to be a 4.
All right, the red 4 down the red 4.
Right, so there's 4 go down there.
Okay, but it should be 5 away. Why don't
It
I...
is.
Well, because
It
it's
is.
the 1.
Oh, it is.
the
1, 2,
corner.
3, 4, 5.
Yeah.
Oh, yeah.
Yeah.
Hey, that's pretty heavy duty.
I like it when he's surprised. Yeah, it's like his invention. And
So the center numbers are moving
Uh-huh.
by that. That's right. The centers are moving.
It's still alive.
yes.
And if you just
What are you saying, Charlie? Say it real loud.
the center numbers are moving according to our circuit, aren't they?
Well, if you do the one right over next, the not only the center numbers, the circuit, which are the doubling circuits, what about the 396, 693? You'll actually have the pattern, which is this it here?
5, 7.
So we'll do right here 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and then the center one.
That's
So,
not-
I took it off by 2. I staggered them.
yeah.
1, 2, 3, 4, 5. So it's kind of confusing. So right now we've got another doubling circuit going in the reverse direction. And if we go over here, we'll have the 396, 693, which will be... Okay, it's kind of hard to do. Oh, here it is.
Right?
Okay, so here we have a 6, right?
Jackfruit even.
And it goes like this. Oh yeah, that's called phyllotaxis in plants. It's the same pattern. And here's a 9. 1, 2, 3, 4, 5. It's making the whole thing with the spaces
Right,
and
so
everything.
That's the self-similarity appearing, isn't it?
Exactly.
And you could do that with 6. You could do that with grids of 6, couldn't you?
No,
You couldn't. So you chose groups of 5 on the
because
side, right?
we've already covered groups of 3,
Right.
and we haven't covered groups of 2. But every one that we choose has another wisdom. 1 will always equal the number in the center.
1. What do you mean?
One box always equals the number in the center. It's, in other words,
right.
I'm going to go 1, then I'm going to go 2, then I'm going to go 3. 2, which is just a square. Again, we're just doing squares.
Oh, I got you. Yeah.
Okay, which is
2 by 2.
okay equals 9. 4 plus 3 is 7. 7 plus 3 is 10 is 1. 8 and 1 is 9. I can take any 4. 3 and 8 and 4 and 3 equals what's it equal? 18
9.
equals 9.
Right.
So even numbers will always equal a 9.
What do you mean?
Even squares.
Even, so 2 by 2s, 4 by 4s,
Right.
6 by
6 by 6.
But 1 by 1 is an odd, and what is a 3 by 3 then?
3 by 3 was making this whole pattern of the 9 at the center, and
But it did come to 9. But
of course I hadn't taken the 3 by 3 and put it off to the side and seen which one what it would have done. Going,
What is a 4 by 4 do?
4 by 4 would have been a 9. Let's do a 4 by 4.
Yeah.
Okay, these 4 groups would have equaled 9.
Okay, what's a 5 by 5 do?
We just did it. Equals the doubling circuits in the equal potential major group.
5 by 5s is a doubling circuit.
Right.
And the-
7 by 7s. Here's 7 by 7s, doubling circuits. Here's no, here's 7 by 7. Here's 5 by 5, and then make the same
How about
pattern.
how about these 9 by 9s? What happens there?
9 by 9s.
Yeah, gives you the,
It's real deep, serious stuff that you have to be a genius to understand.
what
It,
hap-
huh?
yeah.
I'm not the genius.
Oh, you don't know.
It goes 3, 9, 6. I know I should say I'm a genius, but
Yeah.
it's that profound. It turns from doubling circuits and all this stuff. It turns into 3, 6, 3, 6, and then it goes 9, 9, 9, and it all means something, and it's all modeling a higher dimension, and it's just too deep.
Have you done 11 by 11?
Probably not. I think I was happy doing all the analogies and all the different variations, and I was going to leave it for people like yourself to do.
Huh. Well, I'm sure I'll try it.
Okay.
Yeah.
Well, it takes a
What
lot
I
of
need-
paper, believe
yeah, well,
me.
I wish I could get a chart like that, because then you could play all day with it.
A big one?
Yeah, that was really erasable.
Yeah. A whiteboard? Well, if
Yeah,
you pay the
like
shipping,
that.
I'll get you one this big, a whiteboard.
I could probably.
But you got one at school.
Well, you know, one of the things I ought to do with my classes, have them make this.
Right.
See because if they can make this, they understand it,
Take a picture of it.
right?
If they can understand it and explain it, and they can win the Nobel Prize because
But-
they'll
but-
explain it to the world,
But if we
which I
wanna
haven't
work with
done.
it in class, they should be able to. I should be able to explain it to them, and they can make it up and put tape on a whiteboard. And so
And
we should
figure out all the axioms.
Yeah, we could play with it a long time.
That's right.
Do you want to explain to the world?
Yeah, but no, I don't want to explain to the world.
You will.
I want you to explain to the world.
No, you can. You do it much better than I do. Let's make
Well, that's kind of you. But the problem is, see, what do you mean I explain it much better than you?
Well, because you don't
You think I'm going to be able to explain
done this.
in TV sets going vertical and horizontal with the Z thing going back and forth?
You did it right here.
Every one of us have people that circumambulate around us. Okay, we each have our own world of friends and stuff like that. And there's only certain people that will understand, identify, and relate to you.
Yeah, you need experts in their field to get into this, who then could adapt it to their field and see the patterns appearing in their field, who really have done a lot of experimentation, like a biochemist, getting into this and starting to see patterns in
You see, okay.
That's what he said.
I'm saying that, and I'm also saying that that I can't do anything more because, like the experts that he's talking about, I don't have the books, you know, the money to buy these books to study these topics. I don't have the teachers. No,
Now,
I'm not
you
even
gotta
going.
make connections with them.
You'd rather, so you just like to plant the seed so it can grow
Yeah.
out.
The dandelion.
Yeah.
Is that what you want?
The only work that I'm willing to do further on this, per se, is either the periodic table of elements, computers, or biology, modeling genetics. Because my ability is to do stuff that's pretty much impossible for people. Okay, figuring out things that are impossible. And I think the genetics, these are all codes and traces enough of it that people can start figuring it out on their own. But I know those are tough ones. And so I really don't mind approaching those and using my abilities and powers. What I really don't want to do, though, is well, I don't know what I don't have the strength. I just don't have. I'm that spread out too thin. You know. I don't travel to the mainland. I don't. They offer me to pay my airfare. They pay my hotel. I can't handle it. It's just too exhausted. So my goal is that you guys do it. Okay. You
We've got about 15 minutes to take.
Okay. So, the law of numbers, passing on the energy, is the same as the concept, same as all the laws of physics. It's all connected. It's seeing the harmonics and the vibration.
Have you ever seen that before? Oh, you've never seen one of those? That was one of my favorite toys when I was a kid.
Wow. What is it called?
What is, I don't know what it's called.
Newton's
It's
cradle.
an office.
Newton's cradle.
It isn't an office toy.
Okay.
It's a Newton's cradle.
I guess we'll go to the brain. Why not? I told you I'd come back to it. We're down to our last 10 minutes. There's the alphabet, there's the numbers. It's a system used by billions of people. I'm not going to go into that deep. I think we'll go into something that I can teach you that no one else will say. This is neuron migration. I call this life-giving biophysical harmonics. I think I'll go into... There's a lot of facts, a lot of bases that I could explain that by. But I'll just tell you how I know it.